Have you ever wondered what makes your favorite soda so incredibly fizzy and refreshing? That satisfying hiss when you crack open a can, the tickle of bubbles on your tongue, it's all thanks to one amazing gas, carbon dioxide, or CO. But have you ever thought about where that fizz actually comes from? It's not just magic, it's a fascinating journey of science and engineering. Today, we're going to dive deep into the world of carbonation and uncover the incredible story of how CO travels from the air all the way into your soda bottle. So grab a drink, get comfortable, and let's unravel the mystery of the fizz. First things first, where do soda companies get all this carbon dioxide? You might think they just pull it out of the air we breathe, but it's a bit more complex than that. CO is actually found in concentrated forms in various places. One major source is natural underground wells, where large deposits of CO have been trapped for millions of years. It's like finding a natural treasure trove of fizz. Another, increasingly common source is industrial recycling. Big manufacturing plants, like ethanol producers or ammonia factories, release a lot of CO as a byproduct. Instead of letting that gas escape into the atmosphere, special capture facilities collect it. This clever process of industrial recycling not only provides the CO we need for our drinks, but also helps reduce greenhouse gas emissions. It's a win-win for our sodas and for the planet. Once the raw CO gas is collected, it's not yet ready for your soda. It's mixed with other gases and impurities, so the next crucial step is extraction and purification. Think of it like panning for gold. The raw gas stream is passed through giant towers called scrubbers. Inside these scrubbers, a special chemical solution acts like a magnet for CO, absorbing it while letting other gases like nitrogen pass right through. After the CO has been captured, it's released from the solution and collected, but the job isn't done yet. This captured CO still needs to be cleaned up to meet strict food-grade standards. After all, you want your soda to be safe and taste great, right? The gas goes through multiple stages of purification, including filtration to remove any tiny particles, compression to increase its density, and drying to get rid of any moisture. This ensures that the final product is over 99.9% pure CO, nothing but clean, pristine gas ready to become bubbles. Now that we have ultra-pure carbon dioxide, how do we get it from the purification plant to the soda factory? You can't just put a gas in a regular box. The pure CO is cooled down to a chilly -78.5 degrees Celsius, or -109.3 degrees Fahrenheit. At this extreme temperature, the gas transforms into a liquid and sometimes even a solid, known as dry ice. This process is called liquefaction. The liquid CO is then stored in massive, heavily insulated, and pressurized tanks. You've probably seen these shiny, metallic tanks on the back of trucks or at industrial sites. They look like something out of a sci-fi movie, and they're designed to keep the CO in its liquid state under very high pressure. These tanks are then transported to beverage bottling plants all around the world, ready for the final, most exciting step of the process. This is where the real magic happens: carbonation. Inside the soda factory, the liquid CO is carefully warmed back into a gaseous state and piped into a machine called a carbonator. The drink itself, which is basically just syrup, flavorings, and water, is chilled to just above freezing. Why so cold? Because cold liquids can hold much more dissolved gas than warm ones. The carbonator then injects the pure CO gas into the chilled liquid under high pressure. This pressure forces the CO molecules to dissolve into the water, squeezing them in between the water molecules. The result is a highly pressurized, fizzy liquid, just waiting to be bottled. To keep all that delicious fizz from escaping, the carbonated soda is immediately sent to the bottling line. Whether it's a glass bottle, a plastic bottle, or an aluminum can, the containers are filled and sealed airtight in a split second. This high-pressure seal is what traps the CO inside, preserving that perfect fizziness until you're ready to enjoy it. And that brings us to the grand finale, the moment you've been waiting for. When you twist that cap or pop that tab, you instantly hear that iconic PSSSST sound. What you're hearing is the sudden release of pressure. With the seal broken, the pressure inside the bottle drops to match the pressure of the air around you. The dissolved CO that was forced into the liquid can no longer stay dissolved. It quickly changes back into a gas and rushes to escape, forming the millions of tiny bubbles that rise to the surface and create that beautiful, sparkling fizz. So, the next time you pour yourself a glass of soda and watch the bubbles dance, you'll know the incredible journey they took from natural wells or factory chimneys, through purification and liquefaction, and finally into your drink. It's a little bit of science that makes life a lot more refreshing. Thank you so much for joining us on this fizzy adventure. If you found this journey as fascinating as I did, don't forget to hit that like button and subscribe to our channel for more deep dives into the science behind everyday things. See you next time.